Yeah. You do what you gotta do. You do you. So, so sometimes if I ask you to take a derivative of functions, right? If I ask you to take a derivative of function, sometimes I will say take a derivative. But not all the time I have to say take a derivative because there's a lot of things application-wise. I can say, hey, can you find horizontal asymptote, right? Horizontal tangent, sorry, horizontal tangent. Horizontal asymptote is different. Okay, for horizontal tangent, it's going to be like this. Then we say, hey, can you find horizontal tangent? Well, of course we can. That just means take a derivative and then set it equal to 0. Well, we're going to take a derivative of this ugly thing. So what kind of rule is going to be involved? Chain rule, good, because you have outer power than 1, right? But chain rule how many times? Twice. Any other rules involved? Product rule. So you see this is a product of two things multiplied together. And those two things multiplied together, that means you need to do product rule. After you do product rule, each of the parentheses need to do a chain rule. So those are the things that you should think about through your head. And that's how you're going to get better. So let's take a derivative of this. Now, some people did it wrong is because they just take a derivative of this, use chain rule, times take a derivative of this chain rule, and that's wrong. Because you didn't deal with the product. So I'm going to take a derivative down here. I'm going to take the phi down, so 3x minus 2. So you really need to have a neat handwriting in this case. Ethan, Robert, Zach. Xavier's okay. And Derek's okay. Zach is okay. It's just Ethan and Zach and Robert. So I'm multiplying this by 3 because of the chain rule, right? And then I'm going to leave this one alone. So it'll be 2 minus 5x to the 4th. And then plus. Why? I just take a derivative of the 3x minus 2 to the 5th power. So I down to but. Yes. You not just take a derivative of two parentheses. You actually take a derivative of things. It's going to affect product rule. So now I'm going to leave the second one alone and take a derivative of the second one. So it'll be 4 times 2 minus 5x to the 3rd times by what? Negative 5, right? And some people usually forget that. And some people forget this 3. And that's what is going to costly. So those things are pretty costly. So we have this ugly long fractions. Now we got to deal. We did the calculus. Calculus is not hard. The problem this class is not calculus. The problem this class is called algebra on steroid. Or a much harder drug. So now I'm going to factor out a GCF. I'm going to look at a GCF. So I'm going to look at 3x minus 2 first. And 3x minus 2, once to the 4th power and once to the 5th power. So I always told students factor out the most negative. So factor out 4 instead of 5. Because you cannot factor 5. So it'll be 3x minus 2 to the 4th power. So that is this line here. And for the green one, I want to factor out 2 minus 5x, 2 minus 5x, but to the 3rd power because that's the least amount. So it'll be 2 minus 5x to the 3rd. And then we're going to talk about a bracket, which is whatever's left over. So just this first term alone, this is the first term. You take out this completely, and you take out 3 of this. You take out 3 of this. So you're just left with the 15 times 2 minus 5x. And then I'm going to deal with the bottom. So here this is 4 times negative 5, so it's negative 20. So it's been negative 20 here. And what do we have left? Well, we have 3x minus 2 left. So this becomes a little bit easier for your eyes. So that was 3x minus 2 to the fourth, 2 minus 5x to the third, and this one's going to be 30 minus 75x minus 60x, and then plus 40. And that's equal to 3x minus 2 to the fourth, 2 minus 5x to the third, and this one is going to be negative 135x plus 70, I think. So x equal to 2 over 3, x equal to 2 over 5, and then, so you pretty much set it equal to 0. Sorry, I'll write it down. 3x minus 2 equal to 0. Yes, I did make a mistake.
I was asking, when we're doing the greatest common factor, we don't take out a 5?
You can if you want to. It doesn't bother me because you're gonna solve for the 5 anyway. So 5x equal to 2, x equal to 2 over 5. So what are you saying? Can I take out 5? Of course you can. But here you're gonna divide by 5 anyway. So I didn't really care. So it'll be x equal to 70 over 135. You divide by top and bottom by 5, so it's 35. No, by 5 is different. So by 5 is 14. Right? And divided by 5 is 27. Wait, is it 27?
Yes.
27, yeah. And I don't think you can simplify further. So it's going to be here, here, and here. So 2 over 5, 2 over 3, and the 14 over 27.
Oh, we have to do the 5. No, we have to factor out.
This is too much.
This is only in the beginning.
Is that why they're called scary?
Okay, so with that in line, you just say, okay, well, that's it, done. And how do you check the answer? You could just graph this function in the decimals. Now, sometimes the answer doesn't come out because this number, this is horrible by me, because I arranged those numbers are super close to each other, and that's awful in many ways. So it's happened everything between like 0 to 2, 0 to 1 actually. So I'm gonna have to change it a little bit on your scale. So let's see if we can find the answer. 3x minus 2. So let me give you a question for you to start to take a derivative. So f of x equal to, that says 4x minus
How many homework questions are we gonna have?
plus 3 to the 5th power,
Did you say
and then 3 minus 2x to the 6th power. So something like that, I want you to take a derivative. But meanwhile, I'm going to show you how do I do it on decimals. How do I check my answer is correct. So you're going to do this question right here. Windermere School, high school, mourn death of a student. A student died. I don't know, I'm trying to look.
That class is speaking very hard.
Robert is right down.
You never heard the phrase on sport?
2 minus 4x.
Travel? Same as in the thing. I forgot. It's sport.
I forgot the thing was 3 days constantly.
But no, it's body like something like the bigger than you.
Actually, oh, that's
You messed up.
what happened.
No. Yeah, whatever, but you found it. You took bad notes.
What happened?
How do you like factor something?
So they put it out to
Because I got rid of it.
and then they finally get rid of the stuff.
I mean, look at this.
Exactly, that's what I do.
DCF.
No, because if you bring 2 minus 5x.
That's not 4. That's not all of it. That's 4 here. Alright.
So this is how I check my answer. I want you to pay attention on the board right now. As I went to graph it and I plug in all those x values, Daniela, I went to check the graph and I see there was a horizontal tangent on all those 3 places. And I'm going to show you this one is actually interesting because there is 3 and you should see the horizontal tangent. But not only that, I want to show you here, if I were to bring it to the graph, let's just say, this is how I check my answer. I can check my answer from graphing calculator, and there was a lot of way to check a graphing calculator. So, so in this case, I'm gonna see, I think it's this one, I'm not sure. Is that one? I don't think it's that one.
I think it's the 6th, if I remember.
I remember it's this one, right?
The one below that.
This is not it, right?
One below that.
The one below that?
No, I don't think that's.
Is this one?
I think so.
See.
I feel like that's not it.
No, that's not.
Nope, this is not it.
Is that the picture you just, the thing you just took a picture of? Yeah.
I don't understand how you did this. Why didn't you do this one?
Same reason.
Anyway, whatever it is, here you should see a 3 horizontal tangent, especially at this spot. So usually horizontal tangent occur at maximum and minimum. You see that 0.4 and I say 0.6-ish. There is this point right here and this point right here. They are all horizontal tangent. But this one's also horizontal tangent. It's not minimum or maximum. So that's called stationary point. A stationary point is like I'm going up and then maybe you think about coming down, but it was like psych, I'm going to go up again. So it's like going up and then going up again. So that's called stationary point. It's not really a maximum or minimum. So if it's a maximum and minimum here, then that's still a horizontal tangent because slope over there is still as equal to 0. So you can check your answer from decimal. That's the one interesting thing about it. Okay? So you should finish your problem. Did you already finish?
Almost. Wait, are we finding the horizontal tangent? Or
Yep, finding horizontal tangent.
Yeah, no, we're not taking out. We're just putting it in front. Because if you say it's like you have to find what?
Yep.
X to
Just
the
say like
fourth
the
plus
denominator,
x cubed,
all the
right?
answers.
If it's like this, you just factor out x cubed.
What?
It's the exact same.
There's no denominator in this case.
Oh, the answer.
You can't do the largest.
The answer should have no denominator. No. Oh, you should have fractions. I don't know. It should be negative 3 over 4 and 3 over 2, and there's one more, I don't know. Huh?
The one,
3 over 11?
like right here.
Yes.
You take this out from my friend right here.
I've been studious these last 2 days.
Go to
You
one.
being what?
You're taking this out. Go to one.
studious.
Yeah, yeah.
I thought negative 3 over
Take it away. You can just separate them.
Is it negative 3 over 11 or positive 3 over 11?
Because they're all multiplied by each other, right?
Yeah, it's
So
positive.
anything multiplied by 0
Yeah.
equals 0. So if you can just separate it, so if this part equals 0,
Oh, yeah.
and the whole thing equals this part equals 0, so the whole thing equals 0. Thanks.
What? Oh, you didn't factor out a 4. I see. I factored out the 4 because it makes math easier. Okay, what's now?
Okay, if I take this 5, 4x plus 3 to the 4th times 3 minus 2x to the 6th. And there was a 4 here, right? I forgot about that. 4, yep, plus 4x plus 3 to the 5th times 6 times 3 minus 2x to the 5th times negative 2. So that should be a 4x plus 3 to the 4 times 3 times 3 minus 2x to the 5, and then bracket, so it's 20 times 3 minus 2x plus minus 12 actually times 4x plus 3 to the that. So it's equal to 4x plus 3 to the 4th times 3 minus 2x to the 5th. And this one's going to be 20 minus 40x minus 36.
Wait, you mean 60 minus 40?
Can add minus 60, so my bad, this one is 60 minus 40x minus 48x minus 36. Am I doing okay? So 90, it was 88x minus 24.
It'd be negative 80.
Plus, okay. Plus. Okay, so that is equal to 3 minus 2x to the 5th, 4x plus 3 to the 4th, and then x equal to 3 over negative 4, x equal to 3 over 2, positive, and x equal to 88 over 24, which is equal to 11 over, oh, can try to rush through, it doesn't help. 24 over 88, so it'll be 11, and then 3? Yeah, 11 over 3.
And then you just like take the x minus y squared, you know, right above the two answers, it says it there, and then you just like take the x.
Oh, I take away the exponent. Yeah. So some people says, what do I do with this exponent? It doesn't do anything because this, in terms of a pre-calculus, I actually call something called multiplicity. It still occurs as 0. It's just how they behave at 0 is a little bit different. It's like if it's a square, then it's gonna look like a parabola at that point. So it doesn't matter about the exponent.
Isn't multiplicity like how many times at 0? It's like
Yeah, occur at that spot. So at 2, it can occur twice, so be something parentheses x minus 2 squared, something like that. Okay, so the next one is going to be a little bit harder. The next one's x squared, so yes, it's harder. And square root 1 minus x squared. It doesn't look very intimidating, but it's pretty intimidating. So if you focus, you'll get through it very quickly. So here, I have x squared times 1 minus x squared. And you say, okay, how hard is this? Well, first of all, let's talk about some algebra skill. So algebra skill, if you don't have any, which is okay, you factor out the most negative. Factor out the negative exponents.
I don't think it's okay. I think that this results in
Okay, so if I have just say x to the 4 minus x squared, what can I factor out here? X squared, right? But when you factor out, did you subtract that 4 with the 2? Did you do this? 4 minus 2 is equal to x squared. Does that make sense?
Yeah.
And this one minus 1. Does that make sense? You subtract whatever you factor out. Are we okay here? Now, what happens if you have x to the negative 4 minus x to the negative 2? You've never seen this before. But it does happen. It does happen. So, which one's more negative? Negative 4. So, I'm going to take out negative 4. Again, I'm taking out negative 4. That means I'm subtracting that with negative 4. So, negative 4 subtract negative 4 becomes 0. So, it becomes 1. Does that make sense? How about the next one?
X squared, right?
Yep, x squared. Why is it x squared? Because negative 2 subtract negative 4. So it'll be negative 2 plus 4 is equal to 2. So that was the hard part. So let's see how hard is this part. So f prime of x. Well, here we deal with a product rule. And chain rule. And power rule. So we deal with all three rules here. Okay, we deal with all three rules. So let's deal with power rule here first. It's 2x times 1 minus x squared to the 1/2 power. Because this one just, I'm going to rewrite that. And then plus what? Well, plus, I have the next one, which is x squared, times derivative of this part, which is times 1/2 times 1 minus x squared to the negative 1/2 times negative 2x. So that basically a chain rule there. And what's the nice thing is this 2 and this 2, it becomes pretty convenient, cancel out. So what I'm gonna do is I'm gonna find out f prime of x here. I'm gonna factor out the most negative. So what can I factor between those two terms? What do you see in GCF? What do they have in common?
Negative 1/2 power. Or 1/2 power.
1/2 power, good. So this one is negative 1/2. So can I factor out what else though? They also have an x, right?
Yeah.
Oh yes, I remember that simple x.
So they have an x. Why is my delay? They also have x. They also have 1 minus x squared to the negative 1/2. But once you factor out, the first thing I have a 2 left. And what happened 1 minus x squared to the 1/2?
The 3 answer. Negative 1/2.
Remember, it's 1/2
To the negative.
subtract negative 1/2. So that's equal to what?
Regular one.
It's going to be 1 minus x squared to the 1 power. Because 1/2, you take out negative 1/2, so you subtract negative 1/2, it becomes 1/2. And then plus minus x squared, because you take out 1 of the x. So eventually it becomes x of 1 minus x squared to the negative 1/2 times 2 minus 2x squared minus x squared.
Wait, sorry, how did you, did the minus x squared?
The 1/2 and the 2x cancel.
Oh, okay, yeah.
So it's just negative.
And now I make even 2 minus 3x squared times x over 1 minus x squared to the negative 1/2. Oh, not negative 1/2, positive 1/2. So this becomes f prime of x. But this is nice though. This is a little bit of algebra, which is factor out the negative exponents. So it creates a lot of frustration because a lot of students don't know how to handle them properly.
Alright, we're gonna solve.
So what we doing, right? In this question, I'm gonna ask you to find two things: horizontal tangent versus vertical tangent, because you have both in this case. So how do I find horizontal tangent? Well, horizontal tangent is derivative equal to 0, right? So horizontal tangent is dy dx equal to 0. More specifically, is numerator of dy dx, because numerator equal to 0, the whole thing equal to 0. So numerator of dy dx equal to 0. What do I mean by vertical asymptote? Or vertical tangent, sorry. Is dy dx is equal to undefined. So what do you mean by undefined? Well, it's a denominator of dy dx equal to 0. So denominator equal to 0, then that's going to be like this. Question about this part.
Wait, what's the vertical tangent?
Huh?
The vertical tangent.
Vertical tangent? Well, vertical tangent is when denominator of dy dx equal to 0. Why? Why is denominator? Denominator of dy dx, because when bottom equals 0, the dy dx is undefined. So in this case, you have a horizontal tangent at x equal to 0, as well as 2 minus 3x squared equal to 0, which is 3x squared equal to 2, x squared equal to 2 over 3, x equal to square root 2 over 3, plus minus. So that's horizontal tangent. A vertical tangent is 1 minus x squared equal to 0, 1 equal to x squared, x equal to plus minus 1. So there are 3 ht, and there is 2 vt.
Just ignore the exponent, right?
Exponent doesn't matter, because that 1/2 doesn't do you any good. But that's what all the thing can happen. Now let's check out the graph though. I'm gonna check out a graph here. I am gonna go to photo library and I'm gonna pull out this graph. I just did it last period.
Mr. Yu, you have it as minus 3x squared, so wouldn't there be a negative then?
What?
You have it as 2 minus 3x squared.
And then you bring it to the other side to make it positive.
So I'm going to show you on a graph. There was a horizontal tangent right here, which is positive. This part is x equal to positive positive square root 3 over 2. And this is x equal to negative square root 3 over 2. Well, it's square root. And this one's x equal to 0. But there was another 2, it's a vertical tangent. It looks like right here. There's a vertical tangent, which is x equal to 1 and x equal to negative 1. So there was a lot of things happen. There was a 3 horizontal tangent, as well as 2 vertical tangent happen, because there was a denominator happen equal to 0, and this is what happened. Okay, and you can start your homework early, because you have what, 12 minutes? Or you can do the one that is on the homework question, which is that's something to do with this, and you can check with each other. So you can start that question first. So I forgot what the question is, so I'm going to show you. Is so the homework is already. Wait, I thought I posted homework. is this one, number 4. Number 4 and number 5 is very similar. So you can start with number 4.
Do we have to do quotient rule at all?
Yeah, number 5 you need to do quotient rule. And number 3 you need to do quotient rule. You need to do quotient and chain.
Can you go back to the list?
Sure. Do you guys want to take a picture of this before you can get started? Oh, you already have it? No, man. It's on modem. Which part?
Well, there's, what does it say, factor,
Factor out a negative exponent.